My name is Leia, and this is number 1. We have 1/2, which is shaded here, and 3/5 shaded here. So 1 out of 2 pieces and 3 out of 5 pieces. But we can't add these without knowing a common denominator and comparing the numerators. So we're going to have to find the least common denominator, or another fraction that equals equivalent fraction but would have an equal common denominator. So I did the least common denominator up here by multiplying 2 and 5 to get the same amount of pieces they're out of, which is 10. And now we can see more clearly what the values are in the circle diagrams to be able to find our answer by adding and getting 11 over 10, or 1 whole piece and 1 over 10. 2, we have 2/3 divided by 9 over 7. So right here we're creating an equivalent fraction by multiplying the fraction by both the numerator and denominator. And so we have 7 times 9, 7 times 9 multiplied together. And then I just wrote it out expanded right here so we can clearly see this. We have divided by 9/7, now we can divide across evenly better. And so I crossed out the 9s because that's 9 divided by 9, which is 1. Same with 7. 7 divided by 7 is 1. And then you're left with 2 times 7 and 3 times 9, which is going to give you 14 over 27. Well, basically, the invert and multiply by reciprocal method is doing this, but it's not showing the work. And so, as you can see, 2/3 times 7 over 9 is exactly what we have as a result right here, which gives us our same answer. But in the process, we were just creating an equivalent fraction and dividing it across. And so by doing that, we just flip the second fraction and multiply by that second fraction. Number 3, we have 7 and 234 thousandths times 1 and 23 hundredths. So we have the standard algorithm, but how do we know this method works? Well, we're going to start by creating equivalent fractions, but getting rid of our decimal places. So to do this, I'm going to multiply by 1,000 over 1,000. And then this fraction I'm going to multiply by 100 over 100. And then I'm going to get 7,000 times. So 7,234 over 1,000 times 123 over 100. And then this whole product is going to equal our answer, same answer we got over here, which is 166,382. Whoop. But we don't have the decimal in it because we moved our decimal place to the right, just for the sake of multiplying. And now we have a denominator of 100,000. So if we want to change this into decimal form, we know by the power of 10 that we'd have to move the decimal place back 5 places because there's 5 zeros. And so we would still get our answer that we would get same answer right here, but this is doing everything for you in a simpler way. And over here, we moved the decimal place to the right and then just moved it again back to the left. There you go. Number 4, we're going to be dividing these two numbers together. And to do that, we're not going to be using the traditional algorithm first. I'm going to show you how to do it with fractions. So I can write this as a fraction 3 38 divided by 2 6/10 because a fraction bar can replace a division symbol by definition. And to do this in a more simpler way, we want to make the divisor a whole number. So I'm going to multiply this by 10/10 to move our decimal place 1 decimal place to the right to create our whole number. And then we're going to do long division. Okay, so that goes in once, and then we are going to get 7 again, because you would, and then this goes in it 3 times, and you get 78. So you get 1 3/10 as your answer, which is the same as when I did the traditional way. I got the same answer. And I used the trick where you can move it 1 decimal place, 1 decimal place, however many. You move it the same in the dividend as the divisor. Because we did that here by moving our decimal place 1 to the right and then 1 to the right, which is exactly what we'd be doing here as well. Because when we multiplied it by 10 to get our decimal to become a whole number, we end up doing the same process here, and it's just simpler to know that rule so you don't have to go through this whole process. 5, we have 5 over a half times 1/6. So I'm going to show this with an area model, and I have 3 by 1 because I rounded up to the nearest whole up, and that's what we got. And so looking at this grid, let's see, we have our 5 halves over here by our 1/6. So that region on a grid, I'm going to draw a line down, is going to be right here. And this is our answer for our multiplication problem. But we need to compare this shaded region to a whole. And we also need to split it up into equal parts to know what our numerator is as well. To split up in equal parts, we already know where to do that because our tick marks are representing these sections. So now these are fully drawn, and now we can clearly see our sections. So we have 1, 2, 3, 4, 5. We have 5 shaded sections. So that's going to be our numerator, just as if we were multiplying across 5 times 1. And then to find our denominator, we need to compare it to the whole. And to do that, we have 6 over 6, which is 1, by 2 over 2. And in this square, how many equal sections do we have? If we count it up, we're going to have 12. And so that's going to be our denominator, just like 2 times 6. So there we have 12 equal parts and 5 shaded regions.